Dear students, today we want to discuss formation of a differential equation. How to form a differential equation from a given relation. One relation will be given. From this relation, what will be the differential equation? How to find the differential equation? Now, this is a problem. So, the headline given formation of a differential equation whose general solution is given. Now, we consider one simple example. Now, what is the example? Form a differential equation. Form a differential equation from the given relation. Form a differential equation from the given relation. Suppose the relation given y equal to a cos x plus b sin x. This problem is given. We have to find a differential equation from this given relation a cos x b sin x. Now the solution is that before solving this problem, first we have to know how many constant here, arbitrary constant how many, then how many constant we get two constants. Two constants means we differentiate two times and we remove anyhow, do or die, we remove this a and b. After removing this, we get a relation. This will be the required differential equation. Now we start this problem. Since y equal to a cos x plus b sin x. This is number 1 we consider. Now we differentiating both sides with respect to x. We differentiate both sides with respect to x. We get this one. And this is dy dx. Dx of cos x means minus sin x. And this is ddx of cos x is sin x is cos x. We get this one. But our target, how many times we have to differentiate? 2 times. Why 2 times? Because we have two arbitrary constants. So again we differentiate both sides with respect to x. We differentiate both sides with respect to x. We get this one. And this will be d square y dx square minus a ddx of sin x is cos x. Ddx of cos means minus sin. So we write this. And this will be d square y dx square. Taking minus sign common, we get a cos x plus b sin x. So we differentiate 2 times. Our target to remove a and b, but a and b again present here. How to remove this? Again you know a cos x b sin x. This a cos x plus b sin x is y. So we replacing this, we putting y. This implies d square y dx square equal to this whole is y. Using 1. Using the equation number 1. So this whole we get y. So ultimately a and b absent. In this relation a and b absent. So d square y dx square plus y equal to 0. This is the required differential equation because in this relation a and b absent. So this is our answer. This is the required differential equation. So dear students, clear this one? Just you have to remember how many constants here. 2 constants we have to differentiate 2 times. There another relation. So y equal to form a differential equation from the given relation y equal to a e to the power x plus b e to the power minus x. So from this relation we have to construct form a differential equation. Now what is the differential equation? So again we have two constants. That means how many times we differentiate? Two times. So uh, this will be solution since y equal to given a e to the power x plus b e to the power minus x. This is number 1. So we differentiate both sides with respect to x. A d dx of e to the power x, b d dx of e to the power minus x. And this is dy dx equal to a e to the power x e to the power minus x. If we write directly, then we get minus e to the power minus x. We get this minus. But we have two constants, arbitrary constants 2, so we have to differentiate 2 times. Again we differentiate d dx of dy dx a d dx of e to the power x b d dx of e to the power minus x. Again we differentiate with respect to x. Then this will be d square y dx square a d dx of e to the power x e to the power x b d dx of e to the power minus x is minus, this will be plus this. So we get this. Already we differentiate 2 times. Second order derivative we get, but both the constants are present. Now our target to remove the constants. So a e to the power x plus b e to the power minus x, this value is y. So putting y, we get this one. So using 1. So taking this one in left hand side, d square y dx square minus y equal to 0. And this is the required differential equation. In this equation, a and b both are absent. When we already remove this a and b, then this is our required solution. Then this is the technique. These are nothing. Again, we form another differential equation. Suppose this equation is given a x square plus b y square equal to 1. Suppose this one given. Now we have to form a differential equation from this given relation. Now here also we get two arbitrary constants. So from this relation we have to find a differential equation. Since a x square plus b y square equal to 1, this one given. So this is number 1 we consider. So here we have two arbitrary constants. So we have to differentiate how many times? 2 times. After taking 2 times differentiation, do or die, anyhow we remove these two constants. Two constants. After removing these two constants, we get an equation. This equation is the required differential equation. So we differentiate with respect to x, both sides with respect to x. If we differentiate both sides with respect to x, then we get this one. A d dx of x square means twice x. If we write directly, this is twice y dy dx, this one. And dividing both sides by 2, then we get ax plus by dy dx equal to 0. So already we done one time. Again we differentiate with respect to x. Again We differentiate both sides with respect to x. A, B are constant, this will be outside. Dy dx equal to 0. A into 1, A into 1, this is number 2 we consider. A into 1, B, this is product of two functions. Product of two function, this first function d dx of second, d dx of second plus second function d dx of first. Because we know this formula, d dx of uv u d dx of v v d dx of u. Product rule. Using this, we assume this is u, this whole is v. U d dx of v, v d dx of u. So we get this one. This is a plus b y d square y dx square. So dy dx whole square, this equal to 0. Now already we differentiate two times, but both the constants are present. So we have a tension. So what is the tension? So actually when differentiate two times, we must have without constant, but both the constants are present. So we have a tension. Now we use the Navaratna tel, cool thanda thanda. So here we use the Navaratna tel, cool thanda thanda, because we have a tension. After differentiating two times, we must have this relation free from A and B, but both the constants here present. Now we multiplying both sides by x, multiplying both sides by x, we get ax plus bx y d square y dx square plus dy dx whole square equal to 0. We get this. Now we know the value of ax from this ax, taking this on right hand side. If we taking right hand side, this is minus b dy dx. So 2 implies ax equal to, we get minus by dy dx. From 2 we get this one, and putting the result here, ax means minus by dy dx plus bx y d square y dx square plus dy dx whole square, this equal to 0. So we get the value of ax is this minus by dx. Now right side is 0, we dividing both sides by b, this b cancel. Dividing both sides by b, we get minus y dy dx x y d square y dx square plus dy dx whole square equal to 0. And we multiplying this minus y dy dx plus xy dy d square y dx square plus x dy dx whole square equal to 0. We multiplying by x, this and this here also. Now in front of first term, this is negative, this is not so good. So we write on the highest order is first, xy d square y dx square plus dy dx whole square minus y dy dx equal to 0, and this is our answer. So very nice answer. But in this relation, both A and B absent. A and B absent means we are tension free because this is our final answer. Formation of differential equation means our target do or die. Anyhow, we remove the arbitrary constants. If two constants given, we have to differentiate two times. Three constants given, we have to differentiate three times. So this is our final answer. Now we write one nice answer. This is the answer, which is the required differential equation. So dear students, these are very nice solution. I think you are feeling easy. If you are feeling easy this solution, then please like this solution, and please, if you are new in my channel, then please subscribe my channel and click the bell icon. Thank you.